Right then, before we get started, how many people did the homework? Come on, own up. Yes, I know you're doing scroll work. It's very kind of you, mate. It's very kind of you. Well, Mr. Mikroman did it. So, I did. I sent you the link to the GitHub page site. It had all the charpad files in there. I sent you the link to the Discord directory. In fact, I sent you to the directory. Yeah. Put it in Discord, mate. Hang on. Can't remember which channel we put it in. Hunchback project. I'm sure it was in there. No. Oh, I'm sure I put it in Discord. Yeah, Mike. Do you see the link? Which channel did I put it in? I can't remember. I've got too many. Too many. Was it resources? No. General chit chat? No. Right, okay. Yeah, the charpad files are what Stacy did right at the very start. So we might as well use them as a get starter for 10, and then we'll those are bin files. But the charpad file's in there somewhere. The charpad file's there. Twitch streams. Charpad. There, quasi demo CTM. That's a charpad file, isn't it? Yeah, add a charpad file. No worries, mate. No worries. Right then. So, homework. Now, I asked for you guys to do this. That, which was the spiral. Oh, mate, dude, if you can, that'd be great. Because we're starting looking at it, so that would be great. The more the merrier. So, homework time. I asked you last time that this was the spiral of Shallan's thing. And what I wanted you to do and all I asked was to reverse it. But apparently I didn't say reverse. I said mirror. And I got slapped on Monday because people have reversed it. So Mikroman's just sent me his, which is here. Now what Mikroman's done is taken the BBC program. I think it's the BBC program. Is it? It's not. There's a poke in there. So this is a C64 program, basic program, and he's converted it into BBC. Yeah. And it's basically that program that he put in Discord, but he's just changed it to handle the positives and negatives differently. But he's using a self mod location, which is here, and what he's doing is reading the bytes. So these are the bytes he needs to add, and the steps. So -1, -40, +1, +40, and so he's reading the array and then performing the line. And so, like magic, we'll run it. And there you go. It's in reverse, I should say. It's mirrored. See, I told you, Mikroman, it worked. I don't know why your old code on your machine's not working. It works here. But there is a problem with the template, yeah? There is a problem with the template. And as you can see, I've got a modified file here. And if I go into there, and where is it? Not that one. Not that one. Where is it? Well, I must have checked it. Oh, no, it's there. Right. You'll see I've changed it from 1000 to 2000. Well, I've done a bit of research, because when I was doing while I was doing Pet Frogger, which is the game we're going to be doing, I did some research. Now, and what I mean by research is that book, that book, that book, that one, and that one. So I did some research. Oh, sorry, mate, did I wake you up? Google is less weight, yeah. And I found that between 1000, well, from 1000, if you've got disk drives, which we have, it takes space up for the disk buffers, yeah, for each of the disk drives. So from 1000 could be used as a DFS drive buffer. And then I found that when I was doing the conversion of Pet Frogger, I was finding out that I was getting what called channel errors, and I couldn't understand why I was getting channel errors, and I couldn't understand why it weren't building. I thought I'd bust it, but after I'd done a bit of research, there is memory taken up. Did I sleep? There's memory taken up from 1000 for each of the drives, and I think it's 2 pages. So you've got 1000 to 12, and then you've got 14, 16, and I think it's 18, where you get all the 4 drives on. So the true starting point, I mean, I put 2000 because I couldn't understand why it was doing, so I moved it to 2000. But the true starting point from where you can truly assemble from is 1900X. Yeah? So if I change this to 19, and then change Mikroman's spiral, so it's not doing it at 2000, it's doing it at 19. Do the same thing again. There you go. It works. And what was happening was that the assembled program was overriding the disk buffer, and it was causing all sorts of DFS issues and stuff like that. So I'm going to update the template to have the starting point at 1.9. Yeah. I've also found some 0-page locations and some other memory locations that are not used by the BBC whatsoever, where we can use them. I mean, I don't know if you can see this. Let me see if my desk camera is working. There we go. Can you see that writing? Yeah. So all these memory locations are free. So I'll put that on. I'll put that on the template as well to give you an idea of what 0-page locations you can do that doesn't screw up BASIC if you want to do a mix and match. Yeah. So this is Mikroman's spiral, and it works. It works a treat. It's database driven, as in it's data driven. They're all free, sack BASIC. I'm on about that. You know, some people are using BASIC. I mean, there's one guy that's really into BBC BASIC, but I wanted to give some 0-page locations that wouldn't affect BASIC whatsoever if you was doing inline assembling BASIC. Now, my version of Spiral is a little bit more, how can I put this, self-modify type thingy. So if I run this, oh, hang on, I forgot to change it, didn't I? We are now at 1.9. You know what? There's mine. And mine doesn't run off a database. It only has one line drawing routine. Long-winded. I set the start point. Yeah, I tell it how many rows there are and how many columns there are to start with. And then I draw the line. So down here I've got the line drawing routine here that draws the line that just goes through. You know, I've got a number that it does. So initially it starts at 1 and it's doing subtracts. Once it draws the line, it decreases the number of columns. So it starts off at 40, then does 38. Checks to see if I've got any, loads the rows, checks to see if I've still got rows, blah blah blah. But then I change the amount. So it goes from 1 to 40. And then I change it to go from subtract to add. Right, so basically what I'm doing is I load the amount in, which is here, so it's 1. I XOR it with 29 and store it. So that flips between 40 and 1. So if it's 1, the end result's 40, and if it's 40, the end result is 1. So that changes the amount. Then I've got this other one called EOR instructions, and this converts, changes the code inside that routine. So it changes it from an add instruction to a subtract, or if it's a subtract, it converts it back to add. So what I do here is I load that, which is this SEC. I XOR it with 20, that converts it into a CLC, and I store it back. And I take this instruction here, so it's SBC, immediate. I OR it with hex 80, and then I store it back, which effectively changes it from an SBC to an ADC, or if it was an ADC back to an SBC. And I also store it here as well. So that's where the second line is. So I don't have a two calculation routines. I have the one, but this is true self-modifying code. This is not self-modifying an address, which people call self-mod code. This is actually modifying my routine to become, instead of drawing a line that adds, in that direction, or if you switch switch the instructions, it will then draw a line that subtracts, and both that way because of the values. And that was my first cut for the spiral. But the problem is, it was cycle based, and this was a lot of cycles. So it didn't get to the final cut. But I thought I'd show what my first cut was. And this is the kick. This is the kick code. So all I've had to do to change this, right? All I had to do to change this was change the clear screen and change the start point. Oh, and the start point of the address. Yeah. So basically that value there, because that was 04. And that worked straight. So C64 code, by just changing a few things, will work on a BBC. And we're going to put that to the test. It's a good question, mate. To be honest, this would kill you here. That would kill you because it's bytes. It's the bytes is the killer, because you multiply the number of bytes by your cycles. And so bytes is king. You have to... So it's 127 bytes, but we don't know how many cycles. We'd have to run it through Shallan's code and see how many cycles it is. But that's how I did my reverse. And to make it go the other way, so this is the reverse. So the original, right, you've got to remember here, I'm subtracting 1. I'm starting off by subtracting 1, yeah? So we're starting in that corner of the screen. I don't know if that's the right corner for you guys, whichever corner it is. That corner of the screen, and then working his way along and then down, yeah? So you're subtracting. The first line is subtracting, and then going down is adding, yeah? Well, my original one is this one, and if you look at the drawing calculation, it starts with an add, because we start in this corner of the screen and then we add that way. So that was the homework, was to do the spiral mirrored. To take, if you'd done the spiral for Shallan's code in Shallan's routine, Shallan's competition, was to take that code, because we've now got kick working with BBC, yeah, and to make it into a mirrored spiral. Alright, so as you can see, this is kick, and as you can see, I've got a lot of stuff in here. This template is growing by the minute, but I'm going to put some extra details in. I'm going to create a file that says available memory if you're using basic and stuff, so I'll type that all in. But the reason for this stream was to make a base, not a basic as in the language basic, but make a basic game, text-based game for the BBC using C64 code. Alright? But I decided not to use C64 code because I've already got a very basic game, which was my Pet Frogger. So if I load my Pet Frogger up, here we are. So if you remember, I wrote this a long time ago when dinosaurs ruled the earth and computer keyboards were stone push buttons. And basically it is Frogger for the pet. So if I press F, I've got to think F5. Yep, F5. And then boost it. This is what I wrote when I was a wee boy. Wee boy. 1983. I won't be quite a wee boy then. Because at my school we weren't allowed to play games on the computers. We had to write programs, and so I wrote a game in machine code. And basically it's just Frogger. You have to get across. Hang on, I've got to remember the... Oh, what was the controls? Left and right. What was up? Aha! Oh, dead straight away. Oh, we're going. Ah. Anyway, so this is a bog standard text-based game for the pet. Same direction, same dimensions, 40 columns. I wasn't even... Shut up. Shut up. We'll have none of that talk. So we're going to take this game. You've just seen it working on the pet. The pet was 40 by 25, like the Beeb, like the 64, and we're going to convert it to make it run on the Beeb. Now, I'm not going to lie, I've already done it. So, let's just make sure I'm starting in the right place. Yeah. So I'm not going to lie. Ooh. That's the one. There you go. So I've already done it. So if I get lost, this is what I made earlier. But I'm not going to go through the code with you there. I'm going to actually do it again. We're going to do the whole thing again. Yeah. So I've got this as my backup if everything fails. Yeah. So we're going to create a new project. Close workspace. That's it. So we're going to create a new project and we are going to start it off from scratch. So let me create the project. What? Right. So here we go. New file. So we're going to call it vscode.bbc micro.petfrogger, and then we will open that folder. There we go. So we've got a blank thing. So I'm going to copy the template in. So we know what we're doing. So I'm going to copy the template in. And we'll get rid of those files. We don't need them. And we'll keep that. Where's the workspace? Where's my template? Workspace. Copy that. Right. So here we go. So we've got our space. So we're going to create a file called, let's do this BBC Micro, BBC Frogger. So there we go. We've started our So we'll get rid of that so you can see it. So we've started our thing. Now I'm going to open the folder that I've already done just to be on the safe side. And just to make sure, I'll have that open just in case. No, that's the BBC version. Where's the kit version? There it is. There it is. There we go. Right, so I've got the code here. So I may copy a bit of it, but not much. So we're going to take the code from here. And we're going to copy it into there. Now, you've got to remember that this is CBM code, CPS code, not kick. So we're going to have to do a bit of conversion, yeah? Alright, so we're going to get rid of all this, and we are starting at 1900. So we're going to do a find, and we're going to get rid of that and make it that. So that's all the comments done. We'll keep the pointers the same because I didn't change them. So then we've got to put label in front of all of these. And then we need to put colons in front of all of these. This is the easy bit. There's no quick way of doing this. I did try. But you got to do it by hand. Whoops. How many more? Oh, we're only halfway down it. Oh, come on, John. You can go quicker than this. Now you guys won't have to go through this if you haven't used CPS to write any code and you're just doing straight into kick. I have been thinking of writing a kick CPS converter, but now CPS has got kick functionality, and in the first beta of the new version I've not bothered. Right, how far we got to go now? Oh, we're at the instructions. Oh, the end is near. There we go. Right. So we've got some text in here that we need to convert. So we will dot text. And the thing about the text in the BBC is we've got to encode it to ASCII. Because if you don't, it doesn't come out very well on the BBC. You end up with all sorts of artifacts going on. So there's no such thing as screen codes on the BBC. What you poke to the screen is the ASCII code. And that is a big change of thought process, because the PET and the Commodore machines had two types of characters, screen characters and PETSCII, but the BBC only works in ASCII. Right, so let's just get all this done. Right. Right, so I've got a routine. only mode 7 are bitmapped. Oh, yeah, okay, yeah. Mode 7 is like the pet, where it's the character, but all the other modes are like the bitmap mode on the 64. The rest you have to are 8 bytes each, or something daft like that. Right, so let me just do a bit of this. Right, so what I did was I converted all this CPF stuff into text. So this is clear screen, down, down, yeah? But in fact, it's a lot better to do it like that, because that's return, return, because I'm only wanting to go down to. In fact, I'll leave it at AA. So A is down on the BBC, yeah? And we'll move that encoding there. Then I've got this for text 1. So that's converting what was CPS encoding of the ASCII, and I've just coded it for the BBC. And the reason I'm doing this copy and paste, because this is boring trying to work all this out. So I've already done it. You don't have to worry about it. So that's converted that into what this is. And then I've got this at the bottom, which is that. There we go. Now I've got some other text down there somewhere. Yeah, let me just sort the other text down. Let's keep going. Aha, right, that one. Right, so that's home. That's home, not clear screen. So it goes home and then does you're dead. Do this one. That's this one. So congratulations, you made it. And I think there's one more. Yes, there is. There's that one. Which is, you want another go. How can, why, okay. Is my accent coming out? And that is the instructions. Right, so that's all I'm going to copy from here. Oh, well, I tell a lie, there's a little bit more I'm going to copy, but that's all I'm going to do. Your blatant Doncaster English in the you are dead. Stating the obvious. Right, so here we are. We have got a assembled program. An assembly program, and it's for the PET or 64. Could have run this on the 64. We just need to change the memory locations. So there is something in here that we need to sort out. So if I do this, FFD2, we should all know what FFD2 is. Yes, mate. Yes, mate. Not that far. So these FFD2s are not right. Yeah, well, the CPS, it doesn't matter if they're in lowercase or uppercase, it can handle both. So, run away, Matt. Yeah, CPS can handle both. That's why we've got a couple of errors over here, because we've got some instructions in capitals. But we'll get to them. So we need to find the alternative for FFD2 in the BBC, which is char out on the PET. Right, now I have done all the kernel jumps, and this is the last bit of code. Yep, this is the last bit of code I'm going to be putting in here. So these are the kernel jumps that the BBC uses. So I haven't read up about all of them, but I know 2. Right? And so what we need to do is we need to print to the screen. So we need the JSR for that. Now, the JSR for printing to the screen is not what you think it might be. Oh, I see Mikroman's had a guess. Are you sure? Are you sure? Sure. It's that one. OS ASCII. So what we're going to do is we're going to replace FFD2 with that. There we go. So now all the print routines should work. They should all work. And if I think sounds Japanese. We should be able to get this thing working. So where's game start? Oh, let's sort all the errors out. So we need to sort these out. And I don't know why there's a line between all that lot. Right, we have got some capitalization going on here. There we go, another one. BEQ. DEY. So we should be in a state where we can run this. Right, so game start. Where's game start? There it is. So that's doing the instructions. So I am going to put that in there. So we have just taken a PET program. We've done a little bit of converting on it, but we should be able to get it to run. And this is where I oh, did I run that right one? Oh, hang on. I ran the...
Hello, John here. Thank you for following. Hope you enjoy the stream.
Who's followed? Z-Man. Thank you for following, mate. Thank you. Right, where was I? Where was I? Here. Right, let's do that again. So, kick build and launch the emulator. Here we go. There you go. So all we've done is we just changed the encoding of the text to be ASCII from the CPS version, and we changed the FFD2s to OS ASCII. And straight away we have got the instructions. Straight away. Not other than just having to recode the text and do those minor tweaks in the code because it wasn't kick. We've managed to get the instructions. Now the difficult bit starts. BBC Frogger. Okay, hang on. There you go. There you go. Has that sorted you out, mate? Really? Okay, let's put that in. So it's June, isn't it? And we'll get that. In fact, we'll change that because that was my kid name. Right, let's try and centre that up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 30. So that's 5, isn't it? 1, 2, 3, 4, 5. There we go, that's centred. Pick me right apart. No, because, well, it was a Microsoft thing. Can you remember the original Microsoft logo? On the soft, it was a shape, and so on the PET and the C64, Dial Soft was the heart, the Shift S was the heart. So that was my thing back then, but now I'm OSK. Right, so we've managed 707. Capital Y. Are you picking my English apart now? Oh, I'll tell you what. We haven't done live share in a while, so let's get this live share going. Then you can pick me apart as much as you want. There we go. Let's do this live share. Live share. What are we gonna do? I've forgotten how to use this. I've forgotten how to use this. I want guest only. You don't have VS Code on your laptop. Okay, we'll do it. We'll do it next time. We'll just shut it off. Let's shut that thing off. Right, let's go back there. Get rid of it. All right then. And never will. Okay. I thought we could live share it, but there we go. Right. So. The next thing we need to do is we need to find any sort of screen point. Don't knock VS Code, it's alright, I like it. And I have to use it because of work, so. Notepad for the win. So we've got to find all the all the screen locations. So if you remember, the PET screen runs from $8,000 to $8. I think it's 3, isn't it? 3 FF. I think that's where it runs to. Yeah, VS Code is it's in my opinion a really good editor, text editor. Some of the extensions are a bit dodgy, but the fact that you can build your own extension, which I've been thinking of, also helps anyway. Anyway, so the pet screen runs from 8000 to 83FF, and I think that's for the 40 column. I think it goes bigger on the 80 column screen. I think it's twice the size. But we're only running on a 40 column pet, yeah? So anything with 8.0, like here, we need to change. But instead of changing the numbers, we're going to create some constants, yeah? So dot label, and we're going to say cars first row, and that is going to be this number here, 8026, 8026. Right, so we can grab that, and we're going to do the less than of that and the greater than. In fact, that's not the right one. It's not the right one. It's that one there. Oh, go undo. There we go. And that's 7, 8. I keep forgetting it's 2 rows. So we're setting the car's first row, and there'll be another one a bit further down. Here we go. So this is the car's second row down there. So I'll copy that. Which is 80AO. I'm just going to run through all this and change the location. So we got move cars. So we're storing 0 in the low, and we're storing it in the index of the move cars. We load Y with 26, load the high, store it. Then all this does is just runs through doing the 2 cars, doing the 2 things. So we're going to rename that, and so we should get some errors. And there should be 2 of them, I think. There's one there and one there. Just so when I put this on GitHub, it'll be a bit easier to read, to be honest. And all this is doing, it's doing the scrolling that we did on Monday, but not the pixel fine scrolling, but the character scrolling. But it's doing it on 2 levels, yeah? So it's scrolling one row that way, scrolling the other row that way. So we're gonna do that. Let's use some proper labels. Now this one is to move into the left. Oh, get up. I'm not that old. Right, so we'll do the same thing here. Oops. Just use a bit of modern day stuff. So this is all this routine is doing is just moving the cars. So moving the cars to the right, and then this one is moving the cars to the left, and that's it. Here we've got some more screen locations. So let me just do a split screen on that. So we can have the labels up here. There we go. So this, I can tell you that now, that this 4600 is the score. So dot label score. Oh, come on. There, that'll do. 4600. Just get these in line. And then where we're going to place them is 8030. So display score. Oh, come on. That's the extension doing that. Don't blame VS Code for that. That's the extension. Right. 8030. So we are going to do a quick search and replace. So find $8030. I'm going to change it to that. Replace. I'm going to do the same. Whoops. I'm going to do the same for 4600 and change that to be score. Right, change that. Where's the next one? Oh, it's supposed to have moved. Oh, it's done them all, isn't it? Right. Let's get rid of that. So where are we? So we should have done that score. Now this one is high score. So we're going to do exactly the same thing again. And that's 40.
Hello, John here. Thank you for following. Hope you enjoy the stream.
Digital Tenderness, thank you for following. Much appreciated. Welcome to the madhouse. Right. So we're going to replace these again. So high score 4610. We'll just stick that in there. I'm not sure if there's any more. I think these are the only two places. I'm not sure. We'll see. 4610. Let's see if there's any more. Yeah, there's one there. Any more? Not that one. Yeah. That's it. And then we'll look for that one as well. Just to see if there's any. No, there isn't. Right, okay. So back we go. So that's done that. So this is basically to do the this is to display the score and the high score on the screen. So then we go into our text. I've got to see. Let's move that over. Can you still see it? Yeah. Yeah. So this is this prints the clear screen, which is this up here, and then prints the top this here. So that's not doing any screen manipulation. Here we've got some screen stuff. 81817. Did I miss that? No, I couldn't have missed that. Aha, number of success crossings. Equals $8017. So this is the place where it shows how many frogs we've got across. So how have we got any more? Yeah, we've got one there. So that's another. So number of lives 804F. What else we got? So here we've got a zero page crossing, which I called oh yeah, so 8013. Where's 8013? I can't remember what I called it. Ah. So that's the initial location, so 8013. Oh no, it's not 80, it's 83. So great Dan and oh, it's not, it's 66. Right. Let's see, have we got any more screen locations? That looks like suspiciously like one. Yeah. So what did I call it? Oh yeah. Um, 8050. Now, if I'd have done this properly when I was a kid, we wouldn't be having to run through all the code. We'd just be changing all the labels. That's why I'm doing this. So in the future, it'd be easy to understand. We've got another one here. 8320. Where's that one? I've already got that one. That's that. That is wrong. Right, where's that? Where's that setup gone? Here. That is wrong. That's up here. Oh, if I hadn't got that, that would have screwed everything up. And I would have been going, what have I done wrong? So start. There we go, start. Let's just make sure I've got that right. I don't know. I can't remember if it was dollar or not. Start. Yeah, that's right. Right, I noticed when I scrolled up, there was a test. just glimpsed it as it went past. Here we go. Here. Now, is that... That's to do with... Right, okay, that's to do with... Has to do with controls. Okay. Any more screen locations? Let's have a look. Nope, that's it. That is it. Right, so what we need to do now is get some of these 0 pages sorted out. Because we've got some 0 page locations like here. Let's get them done. Let's do it properly. Any more for any more? Thought there was. Here we go. So here as well. We've also got a screen pointer there. Here. Right. Let's do this. Any more? Might as well do this properly. O2, what's O2? Frog location. Make sure I haven't missed one. Nope. Looks okay. Right. So the next thing we've got to do is we've got to do some characters. Got to transpose these screen locations. So we're going to do that now. Oh, I've got it here. What am I doing? Right, so first car, remember the pet screen is from there and the BBC screen in mode 7 it runs from 7C00 to 7 FFF. Yeah, that's right. So here, so that's going to be 7C78. This is going to be 7C80. Oh, that's not going to stay the same. This is going to be 7C30. That's staying the same. This one is 7C42. This one is 7C17. 17. This one is 7C4F. Ooh. This one, right, 7CDF. 7, that's 7F, isn't it? 7F20. 7C50. And that one is 8,000. So these are now the new BBC screen locations, bar the score, and we'll, in fact, we'll move them out of there. We'll put them there. So they're all the screen locations. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Whoa! We have got the same. So the next thing we need to do is we need to find all the characters, because remember the BBC talks in ASCII, and when we poke a character to the screen we use the screen code. So we've got to change the characters. So what I'm going to do is I'm going to just make life a little bit easier. I'm going to copy the labels. So these are my characters. So we've got a character space, character frog, character safe, and character safe boat. And we're going to now find all the places where these are. So here we go. So this straight away, space, character space. That's doing the move. That's okay. That's a space. It's doing the move. High score. Prince. Here we go. What's that? 57. That's character frog. Character frog. $66. That's character. Yeah, that's character safe. 66. Oh, frog again. That is a 0, so that's fine. What else we got? Right, this is the this is the control routine. 57 is frog. $87. Ooh. Place 2. Did I see that one? I bet I didn't see that one. Oh no. Okay. Oh, 87 is 57 in X. Oh. Right, 2A. Ooh, that's one I missed. Yeah, so that is... I missed that one. So that's character dead. See, even doing it, what I made earlier, I still missed some. Right, here we go, 66. That is safe, that's that. Okay, 66, same thing. Character frog. Oh, that's number of rows, okay. Just make sure we got everything. Right. So that... Why are you complaining? Is it because of... Why are you complaining? Unrecognized token. Whatever. Right, so that should work. So we'll take this jump out and we'll see if we break it. Hey, look at that. Looky, lucky. Right. You see the speed? Right, you see the speed of that? Let me load the pet version in. Right, so there's the pet version. So I'm going to close that down because I don't need it. So this is the pet version. And this is the bead version, alright? So let me just get them running side by side and tell me, right? Right, and that's the speed of the beeb. Straight away you can see the difference in the 6502 clocking on the pet and the 6502 clocking on the beeb is we're going to have to slow the game down, right? Because that is quick. Really, really quick. But as you can see, all we've done is change locations and a couple of characters, yeah? Stick it on an electron. Is it slower on an electron? Is it? I don't know if you can run SSDs on electron, can you? Hang on. I've got the electron somewhere. Disk. Okay, load disk 2. Right, so we'll find our disk. That's the one in there. Oh, what's the asterisk? Aha. Oh, I don't like it. Well, I've got a disk in there, so why can't I see it? Oh, electron. So the electron would run at the same pace as the beeb then, the pet, because that was running. Oh, it only supports 40 tracks. Okay. So the electron would run at this pace here, as the BBC runs at that pace, which is horrendously fast. Now, I can't do anything with it because we've not done the control stuff.
Oi, John, pay attention to chat.
No mode 7. Oh yeah, no mode 7. So as you can see, I thought this was fast on the pet, right? This is ridiculous. So we're going to have to slow this down. When we come to it, we're going to have to slow it down. But we're getting there. We're getting there. So we've got all the tracks and we've got everything going backwards and forwards. So it's a case now of doing the control system. So now the control system is a bit on the Beeb is a right. We'll do an easy one first, which is the instruction. Right. So in the when the instruction comes up, right, it scans 97, which is the equivalent. I think it's the equivalent of 197 on the C64, but I think it's a different number for the PET. Right. I think it's 202 or 203 or something, and we load that and then we check for 50 FF, which means a key has not been pressed. Yep. And so if a key's not been pressed, it goes back and it loops until you press a key of some sort. But the BBC doesn't have that functionality. The BBC is that you have to tell it what you're expecting, and it tells you whether you got it or not. And I found in the the game that we looked at, the space shooter we looked at, the code, well, in there, let's see if I can get it up. I'm not biting. I'm not biting. Right, so here we go. So I'm going to load it in Notepad. So the guy has got his routine, his player movement routine in there. And so this is what he does, right? So he's doing this. And what it is there is a function. So let me just paste that in here. There we go. There's a function in the Beeb advanced user guide, right? So let me load it up. So in the advanced user guide, there's a function that's very similar to, I think it's the FX functions. So if I do find and do FFEE, because it's the Oz word. Sorry, the Oz byte. The Oz byte. That's F4, isn't it? F4. There we go. So the Oz byte is similar to doing the FX. Yeah, star FX, blah, 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 blah. But when you look at the call, we have to find what we're looking for. So we're going to select the stream. So one's no. And there's a lot of them. You have to go through it all. So we are trying to find keyboard. And what I was looking for, what I did was I searched for in key, because that's the basic equivalent, yeah? In key. And here we go. So in key, right? And so the things that you're looking for, but there is, here we go, here's the values. So these are the keyboard matrix values. And directly below this, when I was reading the book, it goes, read a key from this call. And so it's FFF40, which is Osbyte. And it says, and it's saying that the accumulator must contain 81. Well, look, the accumulator is containing 81. So I carried on reading, and there's two ways you can use this. You can tell the Beeb, I'm expecting a space. You've got to wait until that space is, and this is your time frame. And so what you can do, you can set the X and Y to be the time limit in centiseconds. Yeah? So it's divided by, every second is divided by 10. And so you can go from 0 to 7 FFFFFF, which is the equivalent of 5.5 minutes roughly. So you can tell a Beeb to wait up to 5.5 minutes for the space bar to be pressed. Nah, we're not going to do that, because we want the game to be continuous. We don't want it stopping while it's waiting for a key press and then carry on. We want it to scan the keyboard, give us whatever's there, and then move on. Well, if you look down here, that's where this is here. Scan the keyboard for a key press. And it's saying for the entry parameters, the X is the negative value of in key. Yeah? And Y is set to FF. So you've got to make sure Y is set to FF and the X is set to the negative in key. Now the negative in key, luckily, in this this table, it gives you the negative in key here in this column. So if you want space, you put 9D in there. Alright? And that is what we're going to do. That's how we're going to operate the keyboard testing system, you know, the control system. So what I did here is I created a routine called check space. Yeah, and X is the space. I need to set X to be the space. So the negative value of space was 9D. Y has to be set to FF, and A has to be set to 81, because that is the function call we're performing. Yeah. So there's other function calls. There's 80, 60 something, all do different things, but hex 81 scans the keyboard. In fact, doing that. So this is now telling the BBC, this is the key I'm looking for, and because I'm setting this to FF, it's doing a key scan, and this is the function I want you to perform, which is scan the keyboard, not wait for a key to be pressed until it runs out of time. So what we do is basically we just do this. Yeah, we just plonk that in here. Just plonk that in there, and then we check the end result. So the end result, if I go back, so on exit, yeah, on exit, X and Y contains FF if the key being scanned has been pressed, right? So X and Y will contain FF if the key that we've asked for has been pressed. If it's not, it'll be any other value. Well, when I tested this, the any other value is that 0. So it only returns back 0 and FF. So if the space has been pressed, it returns FF. Hello. And if the space hadn't been pressed, then it returns 0. So we're going to check with 0. So we are going to compare it and then branch if equal to in string 1. So we want it to go back. So The key's not been pressed, we want it to go back. And then we can get rid of this. That is now our new keyboard thing. So if I run this, if you remember the last time I ran it, it went straight through the instructions and just went straight into the game. So when I run this now, it should stop at the instructions and wait for us to press the space key. There you go. So it's now waiting for the space key to be pressed. So if I press space now, there you go, it moves on. So let's go further up. So let's find the control system. So the control system is somewhere around here. We're looking for the word key. Here we go, key. So there we are. We're scanning the keyboard, checking for FF, and then we are going to key 1, which basically updates the game. Yeah, which updates the game. So the player is still in the same place, but it still lets the game carry on going. But the problem now is that the let's get back. The problem now is when in the pet we load 97 and then we check what the accumulator is. So we're going to key 1. If it's not equal to FF, that means a key was pressed. So we go to key 1. And then we say, was it the same as the key that we've just pressed? If it is, jump out. Yeah. If it's not, then test it with 52. If it's equal to 52, we're going to do the right. If it's not equal to 52, we're going to go and test to see if it's 54. Now the BBC is not like that. You have to tell the BBC what key you're expecting. So we can't do a single load and then test it. We have to run that routine 3 times for left, right, and up. Right? So we've got to change. We've got to change the way that this function works because it works differently. Yeah. So what we're going to do is we're going to create another routine. Where is it? That's going to perform the LDA 97, but do it the BBC way. Yeah. So where's that route? There we go. Check space. So we're going to create one called get user input. So we are. So we're now going to have to check for the 3 different keys. Now, in my game, I'm using the Y register. And the Y register is where the frog is on that line. And the problem with using these OS bytes is it destroys the 3 registers. So I need to store away the dog's down there. Need to store away the Y register. So we're going to transfer Y into A and we're just going to put it on the stack so we preserve the state of the Y register. And then we're going to tell the BBC what we want. So here we are going to be check for the left key. Now, what I mean by left key is I mean we're checking for the key that determines what left is, not the arrow button. Yeah. So I'm going to get the labels that I'm using. I'm going to put them here. Oh, I might as well grab that lot as well. Right. And we are going to build the user input routine to simulate LDA 97. Okay. Are you still with me here? Yeah. So here, 97. We're not checking for 97. We are checking for left, which is that one. So we're checking for the S key, which is effectively 97. Yeah. Then we'll do the JSR tell it to go and scan that key. Then we're going to test the output. Is it 0? That means the key was not pressed. Yeah. If it's not pressed, we're going to branch if equal to get user input right. So we're going to be testing for right. Yep. So we'll do that here. GUI right. If it came back as FF, we're going to load X with a value that we want to return back to our routine to say that we're going left, and that's where this scope comes in. Right, so we're loading X with the value of that we're going left. Yeah. Now I did a bit of debugging, and I will put it in as well. So what it's going to do, it's going to store the result of this key press in 7C00. And the only reason I did that was, in fact, it's got it the wrong way around. The only reason I did that is I wanted to make sure what was coming out of the input routine. And then I'm jumping to GUI return. So that is going to be our return station, GUI return. Right, so we're going to do right. So it's rinse and repeat again. So we grab all that lot, put that in there. This time we are testing for the key right. So this is the key that we're testing for right, which is the D. So we're going to say D is the key we're looking for. It does it, comes out. If it's 0, means we didn't press right. Yeah? So we need to do the next test, which is GUI up. So GUI up. Right, and then we're going to put that in 1, and then this is going to return right. And we just rinse and repeat again for up. So this time we're testing for key up. So up, right, and key up is W, yeah? And same again, we test it, and this time we're going to say no key. So GUI no key. So we've got an instance where there's no key being pressed, yeah? So we're going to put that in 2. And then this is user up. And no key basically is going to say hash, there we go, char space. And then I'm just going to store this to wipe out those 3 bytes. So they're initialized. So if there's no key being pressed, I want them. That is true. That is true, but we don't know if the last instruction that the OSByte did was load X. If there was something else that's been done since load X, then the status registers wouldn't be set correctly. That's why I'm just doing CPX, is just to make sure that we are testing. You are quite right. If we'd done load X on the instruction before, we don't need CPX, yeah? You are quite right. We just do a branch if equal check. But we can't guarantee that the OSByte function has the status set up to warrant that. We can't guarantee it, so we have to do it, yeah, because the last the load X. I mean, the last instruction could be load A for all we know, or load Y with X. We don't know. Load Y with 55, so we don't know. So you are right, but this is an unknown, so we have to do a CPX because we do not know if that status registers set correctly. Okay, so this is just us making sure, yeah. And then LDX hash user input, and it's none. User input none. So on the return, we remember we've got to make it simulate LDA 97. So we have to do PLA transfer A into Y. That re-establishes our Y register. Hey, hello mate, how you doing? And because we are doing LDA in the original program, we're going to transfer the X register to A before we return back. Yeah. So now our accumulator has the result that we want. Good, good man, good. We're getting there here. So we go back to our control center. We find where the LDA is. Here we go. So we're looking for key. There it is. So we're going to run that out. All right. And then we're going to do JSR that. And that routine, the end result of that routine is the accumulator has our end result in it. So we can still test for FF, but we've got a proper variable for it now. So we're going to compare it with user. There was no user input, and it branches to key 1 and then continues. But if there was a user input, then we store away the end result, yeah, and then we run and we go to key 1. Here we go, key 1. So then we test the end result. Now here, right, so we need to test for left because I think that's going left. So we're testing left, and if it's not equal to left, we go to right. So this is left, yep, so it's doing that, and then right is here, so we'll grab that and we'll put that in there. If it's not that, then it's up, so we'll get up, grab that and put that there. So that should now be getting our user input. Yeah. So we should be able to run this and see what happens. See if we've got it. And we'll know because we set the 3 bytes in the corner of the screen as our debug flags. So here we go. So we know about that. We carry on. So here we go. So we've got some debug flags there. Now I can't see me, so let's just see. What is it? S, D, and W. So I'm going to press S. I'm dead straight away. That's because we've got a test in there somewhere. We need to do the, because it's saying I'm dead. Right. We must have missed a character test. Hang on. So our character safe, that's the one we want. So we need to...
Hello, John here. Thank you for following. Hope you enjoy the stream.
Kelso, mate, thanks for following, mate. Welcome to the follow club. I've got quite a few now, I think. Right, so it's the check. So here we go. So check. Excellent. Right. So it's this. It's this. That's character safe. 81. 81. 81. Oh, let me look at my code. The one I did earlier. Check. Here we go. Check. Oh, it is boat safe. That doesn't look right. Well, we'll put it in there. Right, okay, let's try it again. So hopefully we will not die because we're testing the right character. So we're looking up here, yeah? We're looking up here to see. Right, I'm pressing S. There you go. You see it come on and then go off. And look, my little character's moving, look. So now I'm going to press D. There's D. Oh, does that mean I haven't done the... Right, let me just check my debug markers. I'm just wondering if I've set it up wrong. Right, 0. Oh, yeah. That's why. Right, so S again. So there we are. D. Right, let's see if I can hit. W is up. So let's see if I can get on a boat. Well, it came up. It said it, but it's just too quick. Right, we're going to have to slow this down. Got to slow this down. Right. Speed, 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 speed. Where's the speed? It's here. There we go. So this is the speed. So it's set to 30 originally. So if the BBC's running twice as fast, then we'll double it. Yeah, 60. Right, so let's try again. There we go. That's the similar sort of speed as what we've got here, isn't it? That's more like it. I think I can handle that speed. Oh, it's just too fast. Right, so let's test. I'm just a little bit curious why my character's not there, but it does turn up. It's like it's there now. So we'll go and see if we can jump on a boat. There we go. Oh, look at that. I've done the first lane. Oh, look, my score's working as well, look. 30 points because I've done 3 jumps. Right. Let's jump on here. Yeah, I'm on. Ah! Oh! Right. We're doing all right. See you later, mate. We're doing all right. Right, so we need to find out why my frog is not a bit showing. I bet I've missed a character somewhere. Let's just check. The initial setup. Right, let's sort this out. Right, I noticed that when I was writing this, right, so we've got crossed, you know, frogs crossed there, and then frogs crossed here. Not, oh, and there as well. So we're going to get rid of that because I've got it here as well. Char frog to frog location. So the frog location is 7F20, which is the bottom. Don't know why I've got that. Because I think that's further down. Yeah, it is. It's down here. So let's get rid of it. See, when I see it, as a kid, I still look at my code and go, John, what was you doing, mate? So LDY. So this is doing the thing properly now, and then it goes into the user input. So why am I not seeing my character? That is why. Because this is in the wrong place. It needs to be in front of key. Yes, it is. There we go. So we should have the character on the screen now. There we go. So S and U. Right. So you use a W. Right, here we go. W for going across. Oh, that's the first row. Come on, John. Ah! I wrote this game. I should be an expert at it. just rubbish. Just absolutely rubbish. Come on. Come on. Oh, oh, oh. Ah! Right. So there you go. We have the beginnings of the game. So all that needs to be done now is we need to tidy up the messages. You know, because I've got delays in here, but the problem is these delays was equivalent to the pet. So you need to double up to make it do it for the BBC, because it was twice as fast. So any of the delays we're going to have to double up on. So how many of these delays have I got? I can't remember. Looks like it's only the one. Yeah, this is where it goes horribly wrong. We've got the game working and now we're going to mess around with it. Right, here we go. So we've got another set of delays here. And we'll put that in because the BBC is twice as fast. And there as well. So we'll just grab that and put that there. So that's only 4, so we'll take one out. Oh, take another one out. That's it. And I think that's it. Now, this was filling the screen, yeah? So we die. We change the character to be the death character, which is the asterisk. Then we delay, and then we fill the screen. And the fill the screen is just a load of equal signs. Now I wanted to make it a little bit better. Now I was messing around with a character. Which was $FF. So we're going to change that to that. So let's run it and see what it looks like. So I'm going to try and die. Oh, it would help if I was pressing the right key. Oh, you're joking. I'm trying to die. What? I'm trying to die. Come on. No! Right. Try to get the space. Hey! Right. So you see that it did the full screen look. It filled the full screen with those weird characters. But it's doing it all the way at the top, and I don't want it to do that. I want it to... So the start screen is not quite right. So, where's the calculator? So it's 40 times 2, which is 50. 7C50. So why is it filling the entire screen? What? Oh. Cheers, mate. Are you talking about the text in the game? Yeah. I failed English O level. Many times. I failed English O levels 7 times. Yep. Just shows you English is not important. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 30. So that's 5. And I suppose I better have the capital there. Yeah.
Oi, John, pay attention to chat.
I'm also dyslexic, so that says brain to me. Even though I know it's Brian. Come on, you should know I'm dyslexic, mate, because I... Yes, mate, yes. I get the joke. I get the joke. It's only us dyslexic people that could get that. Anyway. So, the fill is filling the entire screen, which I'm not too happy about. Ooh, where are you going? Right, let's see if I can die straight away. There we go. Yeah, it's filling from up here. Why is it filling from up there? There's got to be something wrong with my code. Oh, okay. 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 That's for correcting me spelling. You AMK point troller. 7C50. Why is that? I don't know why that's starting in the wrong place. got no idea why that is starting in the wrong place. Let me just put a there. I want to see what's going on. Right. It's filling the entire screen. What? But the start screen is 2 rows down. Oh, I don't understand that. Why is it filling the entire screen? Ugh. That might help. Right, die. That's better. That's what I wanted it to do. Right, now I've figured that out. So that's filling it, and then we top left of screen. Now we should be able to do right. Let's die again, because I want to make the text come in the middle of the screen. So let's die. There we go. So the text is at the top of the screen, and it's printing. It's printing down. Why is it printing? It's printing LDA 13. 13 should have been home. Yeah, they're my we'll get rid of those. They're my keyboard checkers.
Oi, John, pay attention to chat.
Oh, he does write it. It's just that I blank him out in the keyboard detection routine. It'll be put back to normal, mate, when I've sorted it. I need. Where's the hex code for home? Oh, back. So, up, down, left, right. Oh, this is keys, isn't it? I want the ASCII values. Give me the ASCII table. No, that's all right, mate. It's all right. Look at that. Could even do joystick if we had a joystick plugged in. Where's the ASCII table? Aha! Move cursor down one line. Move back. Just carriage return. Can anyone see where it's home text cursor to the top. 1E. Am I doing 1E? No, I'm not. 1E. In fact, I ought to start making labels of those, don't I? Or constants. Yeah, let's do that. Right, so that sets it to go home and then does print 2. Now what's print 2? Is that up? Print 2. No. That's got to be up. Where's the highlighter? So there it is. Right, it's up. It's here. There we go. Print to. So it loads the number of frogs crossing. Okay. Okay, right, so you're dead is here. So it does the delay. LDA, the text. Prints it. Now, I'm going to put some things in there, right. ASCII, move cursor down. Move cursor down one line is OA. So dot constant so I'm going to put one, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13 for good measure. Right. That's okay, but I need those to be moving over. So move cursor forward one character, 09. So that's going to be right, isn't it? So I need to do 09 2, 3, 4, 5. Right, let's try that. So we should end up with a screen with the message in the middle. There we go. There we go. Now, oh, double height. We've got to have double height. Is double height a ASCII value? It's not, is it? It's Motem control character, yeah. I'm not gonna do double height. I'm not gonna do it. Right, so we need to do the other messages like it as well. So we'll do this one, we'll put that in place. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 20. 1, 2, 3, 4, 5, 6, 7. 27 leaves 13, that's 7. 6, 7. And I think there's one more. Yeah. Oh, OC. What's OC? Clear text area. Right, that's clear screen. Okay. Alright. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. 24, 26. It's 13. Ooh, no. Right, okay. We're going to go, we're going to do this. Y/n. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 30. That's 5, 2, 3, 4, 5. Right, so that's that. So the last thing we've got to do now is what we've just seen is the where it's asking the question, do you want to continue? Now I used, if I go back, I should see, there it is. There it is. I used FFCF. So you typed in yes and you pressed enter. Now we can't do that. So what we need to do now is to do the equivalent, yeah, is to create another one of these user inputs things, yeah, user inputs, and but this is just basically to do yes and no, yeah. So we'll copy that, we'll paste it there, but this time it's not get user input. This is get user answer. And we'll put yn so we know what it is. Now we don't need to keep y anymore because it's at the end. So we need to create some more user inputs. So here, so dot label and user input y equals 01 and label user input n. So we're going to do the same thing there. So we need to get the in key values. Okay, so we need to get the in key values. And we're looking for y, and the in key negative value is BB. BB. Oh, come on. B and dot label key n, and n is AA. Right, so we want y, check for y, and then go to get user answer no. We won't do that, and if it is, we will return that. A return. So this one needs to be n. If it's not y or n, then we go back to here. So we're going to send it back to here because that's the only two answers that we need. So we'll send it back to there, get rid of that, and if it is n, we'll copy that and paste it into there, and then that's going to return. So we'll get rid of that. We don't need the no key, so a return. We don't need to do the pull, we just need to transfer it into A because we are the A is tested. So let's just make sure this is right. So we're coming in, we're testing for Y, it's not Y, then we test for N, it's not N, we jump back round, and we'll loop, but any other one will jump out. Okay, let's do that. So let's find where we were, which is here. So we're no longer doing that. We are doing this. Now, 59, I think, is Y. Here we go. So 59 is Y. So we want that. So we're testing for that. Do you want to play again? If it's not, it goes back to the instructions. If it is, then it sets everything back up and starts again. Right, let's test that. So I'm going to die 3 times. There's number 1. Number 2. Number 3. Right, do you want another go? No. Let's see if that sends us back to the instructions. No. Look at that. Ooh, 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 ooh. Right. We're getting somewhere now. So that's done the user input for the answer. So let's rem out our debugs. Where's 0? There it is. Right, okay. So that's that. So we should have an okay working machine. So BBC Frogger. Press space. Right. W. Oh. W. 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 Come on. Come on. Come on. Get in there. Oh, that was so close. Go, we got one across. We got one across. As the crowd goes wild. So there you go. We have successfully converted this into that, and now admittedly the graphics don't look brilliant, but that's because we're in mode 7, yeah, so I've had to make do with some of the graphics. Now I know for a fact you can't redefine a graphic, you can't redefine a character in mode 7, but we can in other modes. So the next mode that's the equivalent to mode 7 I think is mode 4. I think that's 40 by 25. And so what we can do is then, instead of running in mode 7, is run in mode 4 and then do some redefining of characters and get some characters in there, and to be able to I've still got the November 1983 down here anyway, and then we can make the boats look like boats, and also you know, we could do things like making the, because at the moment everything is the same speed, yeah, everything is the same speed. But what we could do is have different speeds for the different lanes. So each lane is not the same speed. It could be, we could make it, you know, go faster or go slower and stuff like that. So these are things that you do when you want to make game better. But the purpose of today was to show you how you can convert a Commodore game, in this case was a PET. Admittedly it's not written in Kick, so we had to do all the conversions to Kick beforehand. But once you've converted to Kick, it's just a case of working out all your screen points. The keyboard input is different than the Commodore system, where in the 64 it's 197. I think the PET is 203 or something, or 208, one of those numbers. But the BBC is, you have to tell it, I'm looking for the space. Has they hit it? No, they haven't. Right, okay. I'm looking for the space. Have they hit it? No, I haven't. And as in the 64, you say, tell me what's currently being pressed, and then I test for it. You're asking the BBC, have I pressed this? No. Have I pressed this? Yes. Right, okay. And that's how it's different. So what we need to do, I mean, have we got time? Ooh. Is we could now the BBC can do in key. Yeah? The BBC can do in key, yeah? There is a basic command called in key. Oh, where's the examples that they got? Here we go. So you can do A equals in key and then test A. But in machine, when you're using the Oz byte, you have to tell it there are two different inputs. Well, I saw this. You can also use Oz. I'll have to look into it. Or read directly from the keyboard buffer. Yeah. But I did that way, and it didn't take it didn't take much. It didn't take much to work out a routine to simulate what was doing. Yeah, it works. And I thought it was a nice, easy way of trying to explain it. It's a lot of faff if you've got a lot of keys. You know, you've got to test for each key. But yeah. So mode. That was what I was looking for. So I'm trying to find if we can machine code change the mode in machine code. Read the top of memory. I don't want to read the top of memory. I want to change it to a different mode. Could it be that? Only available on the master. Oh, okay. How can we change mode? Andy, do you know how to change mode in machine code? Alright, okay. Oswald, A equals 22, then again the mode number in FFEE. Okay. Yeah, VDU 23. I was going to say, I thought VDU 23 sounded familiar. That's the character definition, isn't it? 23. It's VDU 22. Okay. A equals... So we call A equals 22 into Oswich. Yeah? So what does the mode number go into? Do you have to call it twice? So you have to call it twice? Ah, okay. Oh well, let's try that. Let's try that. So, we start. There it is. Game start. So right at the very start, we load the accumulator with decimal 22, yeah? And then JSR that, which I have got as there. And then LDA hash, I think it's 4, and call it again. Alright then, here we go. Let's see if we break anything. Well, look at that. Yeah. We got to rethink this. Oh, we got to rethink that. I mean, it's doing it. It's all the way down here. Ah, so that's how you change mode. Okay. I think that's gonna have to be for another day. Because that's almost sprites then, isn't it? Anyway, so there is how you can convert a basic, not basic as in basic language, but a basic machine code game, text based, you know, a pet game or something like that, into the BBC. So, homework time. If you are willing to oh, that reminds me, there was 20 AMK points on offer for homework last time, wasn't there? And there was only one person that did it. There you go, mate. Congratulations. Right, where is Mikroman's second? Look at that. So, yes, okay, mate. I'll let you have that. I'll let you have that, mate. And also, mate, if you can help, you know, give me a working overlay. So, I'm not going to say next week's homework because this might take slightly longer to do it. But what I'd like to do is make a game, a text-based game, yeah. Either use the cassette 50 competition games that have just come out. I mean, I've just released 3 of mine on the Patreon GitHub, so you could take the kick code and convert it into BBC, yeah. In fact, that might not be a bad idea. Which one could we pick? Which one could we pick? Oh, the copycat game. Yeah. Yeah, because the code is there, right? The code is there. It's simple. So I think the homework should be to convert the copycat game that's in the Patreon GitHub. So if you're a Patreon user, you can go and grab it. If you're not a Patreon user, let me know and I will take a copy of the source and put it in Discord, on the streaming Discord channel. In fact, I'll do that now. I think it's only fair. If we're going to do copycat, let me do that now. So if you're not on my Discord, there you go. That's the link to get in. If you want to do this homework, then I'm going to zip up the copycat game that I did for the cassette 50. And where are we? Patreon only. Patron only. There we go. Copycat. There it is. Right, so I'm going to... Let's just zip that up. So here we go. So here's my Discord. And in the stream details, that's where I'm going to put it. So here is the code for Copycat that I did for the cassette 50. If you want to do this homework, there's going to be 30 AMK points for it. And just to make sure, I'm writing it down. And see if you can convert that Copycat game to BBC. So it'll be interesting to see what people come up with. Yeah? And I'll have a go. It's not going to be a week one. I might give you... I'll give you 2 weeks for it. Because you know how to do user input. I've just shown you that. I've just shown you how, just by putting things on the screen, how to do printing, how to make sure you've got the right ASCII for encoding. Let's say 2 weeks or something like that, and then next week we'll see if I can think of something else to do on the BBC. I might look at the sprites, how to try and do a sprite, and see if we can do something on that line. I don't know. We might start it and try and learn how to do sprites, because that'll be the next thing. As you saw, I went to mode 4 and nothing worked. Nothing worked. So yes, that'll be... We'll see. So it's not going to be a week one. I'll give you a couple of weeks. It should be pretty straightforward. It'd be interesting to see what people come up with. I'll do it as well to make sure, so you can see what I came up with. But it's a copycat game. Log on to Discord if you're not already on there. Grab the code. The template for the BBC is here. That's the template for the BBC in VS Code. So if you download that, it's just basically you write your kick code in there. You do command, run task, and it's kick build and launch BBC emulator, and it does it for you. So it builds it, creates the SSD, and thank you for Mr. Kebab for helping me do that. Alright. So I think that'd be a good piece of homework to get you guys 6502 coding, but this time for the BBC. And this will be on GitHub. If I put it in Patreon, then only the patrons will be able to see it. You're going to 6502 code for the dragon? Really? That's not a 6502 machine. Okay. Alright. I hope that's the difficult bit, yeah. I hope that's been informative, because I learnt a lot, as you could see by the number of books I read. I'll put these details in Discord about the available memory space if you're trying to mix BASIC with machine code. Buffy time. All right then. Is there anybody that's online? I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.